Students, in this lecture we are going to discuss about the next topic, which is construction technology. The construction technology is a general term. You might have heard it so many times. Coming to the designing and building of structures and the technology of the recent advancements of the technology in the construction, we are going to discuss in this video. The design and building of structures. Some structures have been so beautifully designed that they are considered great works of art, and other structures have become important historical or cultural symbols, while others have ended up as disasters. So there are successful constructions and there are disaster constructions. Okay, so before you come to the class, can you please identify some historical constructions, like some successful historical constructions? Maybe you can come up with some any five historical successful constructions and any three disaster constructions, like which are failure constructions. So try to search online and you might get some information. So you can see that in the picture, the Eiffel Tower of Paris. So it is a wonderful structure. So many years it have been, but still it is an iconic and it is an historical structure. Some structures have been so beautifully designed and they might have come up as a historical or a cultural symbols of the history. What are the problems being faced by the construction industry? There are some problems being faced by the construction industry, and they are inadequate planning and slow to embrace new technology, restricting and using outdated building codes, unfavorable contract terms, and shortage of skilled labor, rules and regulations, delay in project and decrease in cost of labor and materials, poor training instructions and lack of communications, environmental and sustainable issues. So you also can identify some other problems being faced in the construction industry as an activity during the class, and you can understand more better with discussion with the teacher. So these are the some problems being faced by the construction industry, and here you can see these are structures. So the basic definition of a structure is something that is constructed or built or made by joining parts to meet a certain need or to perform a certain task. So coming to a structural member, like building material used with a similar materials to make a structure or a frame. So structurals, there are some other natural and human made. Coming to a natural, spider web, bird's nest, wasp nest, these are all natural structures. But coming to human made structures, all the constructions which we are taking place are human made structure. The design of any structure depends on its use. You can see here construction systems model. So these are the inputs, processes, outputs, people, information, materials, tools, machines, energy, capital, time. All these are inputs of a construction system model. And process, designing the structure, preparing the site, laying the foundation, building the structure. Outputs, the output of the construction project, finished structure, impacts on individuals, and comments from the inhabitants and any accidents or any poor design feedback. So this is a circular process, which is a construction system model. Who designs structure? Civil engineers design structures, like civil engineers, structural engineers, architecture. So here we are going to check out the responsibilities of civil engineer, responsibility of structural engineer, and responsibility of an architect. The responsibility of a civil engineer is to design and supervise the building of structures that service the public. Design and supervise the building of structures that service the public. Most work on roads, water supply, sewers, and some public structures. Structural engineers are like who works on designing and supervising of the like public services and waters, roads. Those are generally called as civil engineers. Coming to structural engineers, civil engineers, they're all civil engineers, but whose work focus more on the Load bearing activities like whether the load is sufficient or design, analysis and design aspects will be looked over by structural engineers. Coming to an architect, someone who designs buildings and often oversees the construction, like who take care of the building plan, interiors, exteriors of the building, the aesthetic appearance, the visual appearance of the building, planning, room dimensions, everything is under architecture. So these are the basic definitions of what the roles and responsibilities of civil engineers, structural engineers, as well as an architect. So coming to designing structures, like you all know that designing structures is like analysis, calculations, load bearing, these comes under designing of structures. So we will be learning more about what includes in a designing of a structure. So coming to types of structures, so there are buildings, roads. You are all aware of buildings. Again, we have studied in the previous classes about the buildings. Various types of buildings are there: low-rise buildings, high-rise buildings, structures, roads, and all. So usually defined as a structure with roof and walls is generally called as a building. So buildings might be temporary or a permanent building. Coming to roads, the examples of roads are highways, streets, and other roads. Highways, major roads through and around cities, usually vary in 2 to 8 lines. You know, express highways in our places, and you know how the street roads are, how the express highways are. Street roads are one side only, like small roads in your streets. Express highways are 3 lanes, 4 lanes, something like that. If you go to Dubai, you can see 6 lanes, 8 lane roads also. Nowadays in Oman also we have constructed a very huge number of lanes in the outskirts. So these are all about roads. And you might have seen tunnels. You know about the tunnels. We have recently while going to Ibri, so you might have seen a tunnel, like which is an underground passageway built to allow people or vehicles or materials to pass through or under an obstruction. 3 types of tunnels, like earth, which are dangerous to build, constructed inside the soil, or immersed, which are floated to site then sunk in trenches, like half and half. Rock, like blasted or drilled through the rock with machines, like rock tunnels under the mountains. I think nowadays we have this Ibri is under the mountain, rock tunnel. So the structural forms, you can see there are various types of structural forms, and these we are going to discuss in our class, because I don't want to make this video a very lengthy one. So we will just go through it, like mass walls, framed structures, substructure, superstructure, and we have to check out performance requirements, which is durability, thermal insulation, protection from the weather, acoustic insulation, flexibility, aesthetic, suitability, and buildability. So coming to types of structures, you can also see dams. We will explain in the class. Canals, bridges. So now coming on to forces on structures. There are various types of forces on structures. You might have studied it in the previous semesters. Forces can be external or internal. Okay, and there are you know about the load is an external force acting on an object. There are 2 types of load: static load and dynamic load. So you can know this static load is a dead load. Dynamic loads are live loads. Snow loads, earthquake loads. So forces on structures, you know more about tension, compression, torsion, and shear. We will discuss more in detail in the class. So here there is a construction revolution, which is about modernization, client satisfaction, teamwork, innovative processes, products and tools, and the whole life cycle approach. So from here we will discuss it in the next class. Okay students, thank you.